Okay, so what are we going to be talking about tonight? Okay, well, this slide here is the most important slide that you're going to be getting this evening. And it's the specific lecture objectives, the purpose of the talk. Okay, so these are the things that you're going to be taking away of yourselves at the end of the evening. So by the end of this evening, you will all be able to discuss at least 2 brain scanning techniques. Okay? Now, this is very important because these techniques, they're appearing every day, more or less, in the news. Okay? So it's very important to know a bit about these various techniques. And to make it a bit more exciting for you, if you like, I'm going to put it into context, and I'm going to be talking about 2 social processes. Okay? And in the title, that's Sex and Lies. But really, it's interpersonal attraction. Okay? It's the process that we all do every day. Sometimes we don't even know that we're doing it, and that's assess people for their relative good looks. Okay? And as we're going to find out a bit later on in the talk, sex and lies really, they may seem quite distinct, quite different things, but they've got a lot of overlap. In fact, they're remarkably similar. As we go on, I hope to demonstrate that to you. Oh, sorry. Got this thing here. So let's begin, and let's take advantage of the glorious facilities that we've got here at the think tank, okay? So what I'm going to do is I'm going to show you 2 pictures, okay? They're going to be 2 pictures of 2 good-looking guys, and I want you to vote, okay? I'm going to show you the pictures first, so you don't have to grab for anything just yet. The first picture is this guy here, Hollywood heartthrob and multi-mega billionaire, Brad Pitt. He's actually wearing a sequin dress, in case you didn't notice. And the second picture is me, looking all academic, okay? All right, thanks, Mum. Okay, so what I want to do, I want to see if I can actually work this out without any help. But the question is, who do you think is more attractive, A or B? Okay, wait for it, wait for it. Okay, can you vote now, please? So if you grab your handheld response pads and make a vote, either A or B. You can vote twice if you like. Don't know why you'd want to do that, but you can if you like, all right? Okay, all right. Every vote counts, okay? Has everybody voted? You've not voted? Oh, okay, all right. Okay, let's see if I can work this now, okay? Show results. Oh, voting system, yeah? Voting system. Show results. Screen 3. Oh, hey. Oh, oh, you guys. Okay, well, thanks very much for voting me as being more attractive than Brad Pitt. I don't know why. Yeah. Amazing technology and an amazing demonstration as well. Okay, you guys, I mean, 67% of you, I think it said, 67% of you actually consider me to be more attractive than Brad Pitt. Okay, 30-odd%, I can't really see from down here, 30-odd% think Brad Pitt's the most attractive man out. Okay, well, true. I mean, this guy's been voted the most sort of sexiest man for 10 years running. You know, he's a mega star. He's everywhere you see it. Very high exposure. Okay, but the point that I'm trying to make is, though, some people actually considered me to be more attractive than him. So what are the processes, okay, that you guys were going through in making that decision? I'm going to try and go back to the PC. All screens. Oh, I've got it. I can do it. Yes. Okay, you need a PhD to operate that. Okay. So, well, you know, yes. Brad and I do have a lot in similarity. You know, we're very similar in many respects. That much is true. But there are differences, okay? And it's the assessment of these differences, okay, that you go through in judging your beauty, judging beauty in the everyday world, in the everyday life, okay? And it's different, it's distinct, okay? No 2 profiles, if you like, no 2 decision-making profiles are the same. Whatever you find attractive, okay, is going to be different to what you find attractive. Whatever you find attractive is going to be different to what you find attractive in the morning and the evening. It differs a lot, okay? So what are the processes? What do we consider? Okay, what are the decision-making processes that we go through when going through this? And where in the brain is this actually taking place? Oh, is that going back? Oh, sorry. Oh, how embarrassing. Oh, dear. Okay, gotcha. Hey, so I've never used one of these before, I'm sorry. Yeah. So a few years ago, okay, so where in the brain, and what are the processes that are actually taking place when you see somebody that's attractive? And where in the brain is this process actually taking place? Okay? Well, a few years ago, I was working as a research scientist for the US government, and I tried to address that question. Okay? I tried to look into that and answer that question. So I wrote a paper. I carried out a review of all the studies that have been carried out, that have been published, looking at the neural correlates of beauty, looking at the neural correlates of interpersonal attraction. So the paper came out in a journal called Neuron, and for a couple of days I was a rock and roll star. Everybody loved me. But what did I actually find? Oh, I'm sorry. Okay, here we are. Okay, so what did we find? Well, here we've got a rendition of Sandro Botticelli's Birth of Venus. Okay, it's the head of Venus from the painting, Birth of Venus. Some say she's the most attractive woman, the most beautiful woman ever to be painted. I don't think she's all that, but you know, it's each to their own. What are the various things that Botticelli has actually put onto the painting that has made generations of people actually fawn over her beauty? Well, there are a variety of things. I've just put a little list here, just to summarize the list. It's by no means comprehensive. But if we just take a look at her face, okay, when you consider Venus's face, well, she's got the head relief here. She's got long, wavy hair, long, healthy, wavy hair, okay? So then she's flicking it in the wind, okay? Well, hair, okay, is actually an advertisement for health, okay? If you're in bad health, okay, you actually have bad hair, believe it or not, okay? Clear skin, symmetrical face. Again, these are advertisements of both genotypic and phenotypic health, okay? But Botticelli's done something else as well. What he's done, which is very clever, if I do say so myself, is he's actually painted her with a very long neck. And he's actually put this device in here. He's actually put an extended line here on her neck. And that accentuates the length of her neck. You can see among you all now, females have longer necks than men. It's a sex trait, okay? You look around you now, okay? You guys at the top. Even with my bad eyesight, I can see the girls have got longer necks than the boys up over there, okay? It's a sex trait. Botticelli's painted that into the painting, enhancing her femininity, in turn enhancing her beauty. It's all very exciting. Taking the long neck aside, okay, these cues here, these things here, all advertise health, okay? I hate this thing. Is that the right way? Oh, okay. So where in the brain, it didn't work like this in rehearsals, by the way. Okay. So where in the brain is this process, is this assessment of health, of genotypic and phenotypic health taking place? Well, lucky for us, okay, when you see somebody that's attractive, your palms sweat, okay? It's not the normal kind of sweating that you feel when you're hot. It's not the normal kind of sweating that you undergo in thermoregulation, okay? It's a special kind of sweating, and it's called ecrine sweating, okay? Now, ecrine sweating only occurs on the volar surfaces of your body, okay? Your volar surfaces being the palms of your hands and the soles of your feet, okay? Now, evolutionary, okay, that was when we were monkeys climbing up trees and what have you. Okay, if we saw something that we needed to act upon, it acted like a kind of adhesive, if you like, helping us to climb up trees and escape threat, okay? So that's the evolutionary vestige, if you like, of ecrine sweating. But ecrine sweating has very distinct properties, and it's possible to actually measure the electrical conductivity of this kind of sweating. And we do that, by connecting it to a computer and measuring the galvanic skin response, okay? So effectively, okay, we can measure when electrical conductivity of the ecrine sweating on the volar surfaces goes up, okay, the amount of ecrine sweating goes up, and we can see that we're more aroused, okay, we're more psychophysiologically aroused. Okay, let's press the right button. Yes. Okay, so here we've got a GSR trace. It's an actual GSR trace that's taken from somebody when they were presented with attractive faces and unattractive faces, okay? Now, I'm going to try and get it going. It is a video, and I really want to see, just to show you exactly the differences involved in attractive faces and unattractive faces, okay? Okay, I'm pretty sure this isn't going to work, but I'll try it anyway. Oh. Come on, come on. What's that? Okay, it's not really working, I'm afraid. I've got no idea why. But I'm going to just show you. Okay. It may be this peak here, for example, versus that peak there. Okay, so look at the vast differences here. I do apologize, the video didn't work. So somebody, okay, one of the research fellows at Aston University was presented with attractive faces and a face of me, a picture of me, okay, when we connected her to a GSR trace. I'm not going to mention her name, okay, because she's actually sitting behind me at the moment, okay, but this, okay, is the trace, okay, when this person was presented with a picture of Brad Pitt, okay? This is the trace here when this person was presented with a picture of me, okay? Yeah, there's activation, okay, there's psychophysiological arousal, okay? This person did secrete eccrine sweating from her volar surfaces, okay? But there's a difference, quite clearly there's a difference going on here. Okay, so we can use GSR to measure attraction. We can use GSR, this difference here is the Brad Pitt difference, okay, compared to mine, to measure appraisal of that particular picture. Okay, so that is... Okay, so that was the sex part. Okay, now what about the lying part? Okay. Hopefully this is going to work, my little animations, okay? So lying, like the interpersonal attraction, like the appraisal of people who are attractive, okay, we all do, okay? We all do it every day, okay? But unlike interpersonal attraction, unlike the appraisal of people who are attractive, we're actually very bad at it, okay? And we don't like to be caught out doing it. Now, I put a picture of Bill Clinton here, just because he was the only person, he was a person that actually lied, got caught, he admitted he was lying, okay? But I'm not singling him out for any kind of treatment. Oh. Ah, now it happens, okay? And this list here, okay, is just it's not a comprehensive list by any means, but it's just a collection of the different things, the leakage, social leakage is what we call it, that you undergo when you're confronted with, when you're actually doing deceit and you've been confronted by it. Now, some of the things on this list, I'm sure a lot of people have heard of before, okay? Things like over-denial, stuttering, hand-wringing, no, it's not right, no, it wasn't me, no, that kind of thing. But some of the things I've not actually heard of before, things like disparity, a mismatch between the tone of voice and the expression. Oh, I don't think so. No, that's not quite right. I'd never heard of that before. It's quite surprising. Now, I found this. Now, I found this actually this morning when I was doing a bit of research for this talk, and it's a website that actually trains people to lie. Okay, it's a website that actually enables us all to become better liars, okay? To escape all of this social leakage here. And what they've done, I don't know who this Phil Reynard chap is, but what he's done is he's put like a 10-point list up on his webpage, and you've got to follow the lectures, you've got to follow the lesson plans. You pass one lesson, you go on to the next lesson, and ultimately, after 10 weeks, I think, you become a brilliant liar. Lesson 1 is this. Try to convince somebody that something they just saw didn't really happen. Duh. You know, if you can do that, then really you don't need a lesson plan. You know, I mean, that's pretty amazing stuff. Okay. But what I'm saying is, the point I'm trying to make here, okay, is that, yeah, we do lie. Okay, everybody lies. I'm not just saying it's a cold, brutal untruth. Okay, it can be a slight swaying of the truth as well. Okay, we do it all the time, but we're very bad at it. Okay, we don't like doing it. We do it for social expediency, but when we're confronted with it, okay, it's very nerve-wracking. We're very anxious about it. So, what I'd like to do now, okay, is just to again use the amazing facilities that we've got here at the think tank, and just to see how good you guys are at lie detection. Okay. So I'm going to show you 2 videos, okay? One of them is a lie, is a blatant lie, and the other one is a statement of truth, okay? So what I'm going to do first of all is I'm going to show you the videos, and then I'm going to switch on the voting system. Okay. This is video A.
In the morning, I ride the bus to work.
It worked. Did you all, at the back, did you hear that? Yeah. Cool, okay. Does anybody want to hear that again? Yes. Oh, okay, great, okay.
In the morning, I ride the bus to work.
Good to go? Cool.
In the morning, I drive myself to work.
Does anybody want to hear that one again? Okay, great. Yeah.
In the morning, I drive myself to work.
2 videos, A and B. One of them is a blatant lie, and the other one is a statement of truth. I'm going to activate the voting system now. Calm down, okay? And then I want you to vote. Voting system. Next. Good to go. Go for it, all right? So A or B, your vote counts, okay? Everybody's vote counts, okay? Has everybody voted? Have you voted? Yeah? Everybody voted? You guys up there, you voted? Cool. Okay. Let's see if I can do this. So show results. Yes. Oh, wow. Check that out. Oops. Screen 1. Excuse me. Sorry. Yay. One of those videos was a lie. The other one was a truth. Look at that. It's a virtue. It's a 50-50 nearly, okay? Hopeless at lie detection, okay? You know, don't hate yourself over this. It's quite all right, okay? Yeah, but isn't that a startling effect, okay? I just wanted to demonstrate, to see like a group of people, and we've got about 100 people in this room at the moment, okay? 100 people, you can't tell a lie from the truth. Amazing stuff. Well, granted, it was an impoverished video, okay? It was done just a few minutes before the talk here. You know, Kenny's like, I think it was on your phone, didn't you do it, or something like that. So that's not a problem. Don't hate yourself over that. The point I wanted to make was that how difficult it was to actually spot a lie, okay? Which you've proved quite adequately. Let's get back to the talk. Come on. Yes. I mean, yeah, great. Okay, brilliant. So you've proven, okay, that you can't tell a lie from the truth, okay? And I'll tell you which one's a lie in a few minutes' time, okay? But we've got more GSR, okay? Just so happens for us, when you lie, okay, and you try to keep a lie, try to keep deceit inside and not actually expose yourself, you know, not actually deliver the truth, this happens. I'm praying this is going to work, because it's quite... I really want to do it. Okay, the animation's not working. That blip there was actually the GSR trace for the statement of truth, okay? So that was the lie, which is all screwed up anyway. Okay. But let's just see if you can actually detect when the lie actually occurs. Okay. So this is a GSR trace from somebody who's just told a lie. Maybe there, you know, just in case, okay, you know. So this is somebody who told a lie and was interrogated about it. You know, are you telling the truth? Are you telling the truth? You know, this kind of thing. So anxiety provoking. Let's just get this off right now, because otherwise I'm scared it's going to break the whole presentation. Okay, so that's a galvanic skin response trace. That's a psychophysiological measure of a lie, truth and untruth. Okay? Okay, brilliant. We're doing okay. Let's get rid of that. But what else? What is going on? What is the thing that's actually driving this GSR trace, okay? It can't be the case that when you lie, you find somebody attractive, and vice versa. It can't be the case that when you find somebody attractive, you're actually lying, okay? There's got to be something going on, okay? As you just saw, there's a anxiety-provoking picture that just flashed up behind me. Yeah. This picture here. Your GSR, psychophysiological arousal, shoots up. In fact, it goes right through the ceiling when you're presented with pictures like this. Now, hands up, anybody in the room who finds this picture here, this thing, attractive. Okay, put your hands down. Yeah, thanks. All right, you know. Hands up who thinks this thing is lying. You know, of course, you know, it's not attractive, it's a great white shark. Okay, what are the things, what are the processes going on in your mind when you see a great white shark, when you lie, and when you see somebody that's attractive? It can't be fear, okay? Everyone's thinking, well, I'm scared. I'm scared I might get caught lying as well. Well, you know, when you see somebody attractive, you're not scared, are you? I don't know. I am, but it's probably I don't have a girlfriend. But it's like, it's a anxiety-provoking thing. So where in the brain is this thing actually, these things actually processed? Come on, you can do it. Okay, well, your GSR trace, your psychophysiological arousal, the same feeling that you have when you see somebody that's attractive, when you lie, when you see a great white shark, when you stand out in the traffic and a car beeps you and you jump back in, is mediated by one part of the brain, okay, ultimately. And that part of the brain is this thing here, which is called your amygdala. Now this is a post-mortem slice, okay, which means it's just somebody's died and has given their brain to medical science, and they've taken a picture. This is my model brain, okay, so just imagine the brain turned upside down, okay, and one of these things here, the temporal lobe, has been removed, okay. So you pass the brain around, make sure everybody grabs the brain. Things just gone off. And these things here are actual brains for you guys. There you go. There's one over there. Okay. Oh, sorry. Yeah, okay. Take out a window there. Oh, there you go. All right. And that was courtesy of the Dana Brain Alliance. All right, thank you. All right. Sorry. So, oh, sorry. Did I throw the brain? Oh, sorry about that. Sorry. Yeah. I think there'll be plenty more brains afterwards, actually. Is that right? Where am I reading this from? Sorry, Kenny. Sorry. Yeah. Okay, so that's a post-mortem slice. Okay, that's a photograph of somebody who's died and they've had their brain removed and it's taken a photograph of it. Okay, and it shows the anatomical location of this amazing area of the brain, this mythical area of the brain, this area of the brain that I've spent nearly 10 years studying, called the amygdala. Okay. this, come on. Oh. Okay, come on. We're going to get it. This, okay, all right, is actually a functional map, okay? It's actually a map of 100+ studies that have actually used fear or anxiety-provoking stimulus to evoke amygdala activation, okay? And you can pull this image off Wikipedia, because that's where I got it from. And I like it, because it's kind of got like 2 little eyes and a little mouth there and everything. Okay, that's why I like this particular image. Okay, so that's the functional resolution, the functional location of the amygdala. And that leads us quite neatly into our next technique. Yeah. Okay, which is MRI, which is fMRI. Okay. Now, it was at this stage where I did actually want to dazzle you with science and actually connect over via a wireless link-up to the MRI laboratories over at Aston University. But unfortunately, various factors stopped us from doing that. I'll tell you about it afterwards. But what we're going to do instead is not connect over via Skype or one of these other wireless things. I'm actually going to show you a video clip that both myself and my colleague, John Woods, who's sitting over there, all right, actually recorded yesterday. So I actually want to show you what the inside of an MRI laboratory looks like, and also what an MRI scientist actually looks like as well. Okay? So the next time you hear in the news, scientists have found the area of the brain for this, the area of the brain for that, you'll have some idea of exactly where it is, who is actually finding these areas, and where the data comes from. Okay. Yay. Okay, so this is a video clip. It probably won't work, but I'll show it all the same. It did work.
Welcome to the MRI lab. Okay, so here we are in the MRI corridor. We're going to go into the MRI laboratory. As you can see, very secure area, and we take a lot of precautions over what we can actually bring into the MRI lab. So what does an MRI scientist actually look like? Well, let's go to the control room and meet one. Here we've got an MRI scientist.
Hi, my name's Liz. I'm an MRI scientist.
So that was Liz, and she's an MRI scientist. So as you can see, we're all fairly normal, standard people, okay? So nothing really alien and special about us, okay? All right, whatever. So what does the MRI scanner look like? The actual magnet, the thing that looks into your brain. Okay, well, you come with me. And this is the magnet ball. This is the thing that looks into your brain. So you lie on this bed here, go into the magnet ball for a number of minutes, and we'll take pictures of your brain. And now let's go.
If you'll excuse the sort of the camp gestures when I was in the MRI lab, I'll leave you with my ear. So yeah, so that was just a quick overview. I just wanted to show you. Oh, stop, please. Yeah. I just wanted to show you an insight, if you like, a quick snapshot of what an MRI laboratory looks like and what an MRI scientist looks like. Okay. So that's the MRI lab, but how does the machine itself actually generate data? Okay, how does the machine actually generate brain activation? Okay. What am I trying this for? This doesn't work. Ah, it does. Okay. Here we have a stimulus. Here we have a visual stimulus. Okay, it's a picture of our man Brad. Okay, doesn't necessarily have to be a visual stimulus. When you're doing a brain imaging experiment, it can be anything. You can have acoustic stimulus. You can have tactile stimulus, olfactory, anything you like, really. It doesn't really matter. In fact, we can show anything to people in the brain scanner. So when you're in the brain scanner, and you're presented with images like this, what happens is blood, oxygenated blood, will go to certain areas of your brain. Okay? We don't really know why, but we do know that oxygenated blood will travel to those areas. The proportion of oxygenated blood to deoxygenated blood, okay, will get bigger and bigger, okay? And lucky for us, okay, oxygenated and deoxygenated blood, hemoglobin, has different magnetic properties. And we can use the difference in magnetic properties to produce images that look a bit like this. Quite beautiful images, quite astounding images, in fact, okay? And this is what the whole process sounds like. I knew it was going to end, don't worry. So that's a quick overview of MRI, okay, of fMRI, and that's what the process actually sounds like, okay? So now what we need is an experiment. The question we're going to be testing is the amygdala activated for attractive pictures? Come on. So for that, we need some attractive pictures, and here we've got two. Brad Pitt and his wife now, I believe it is, Angelina Jolie, okay, two attractive people. Okay. Now, this slide I'm going to show you contains data from a report that was published in the journal Current Biology last year, and it's actually quite radical. It's actually quite an exciting finding. And I'm going to walk you through the data, okay? Yes. Okay, so what they did was they actually showed 40 participants, 40 subjects, faces, attractive men and women, and unattractive men and women. Now, the 40 subjects that they tested consisted of 10 heterosexual females, 10 heterosexual men, 10 homosexual females, and 10 homosexual men. Did they get amygdala activation? Well, this slice here corresponds to this yellow bar here in the brain, and this slice here corresponds to this yellow bar in the brain. The model brain that's floating around, who's got it? Oh, great. Okay, cheers. So you'll have an idea of where in the brain these slices actually correspond to. Now, yes, so the main effect of beauty, when you look at all the attractive faces, you do get some amygdala activation. It's a bit dorsal, it's a bit high up, but it's in the amygdala all the same, okay? Now, that's exciting in its own right, but this is very exciting. This cluster of yellow activity here is slap bang here in the front of the brain, one of the most evolutionary advanced areas of the brain out, okay? The orbitofrontal cortex. Now, we're going to be talking about the orbitofrontal cortex in a few slides' time, okay? This is the area of the brain that's responsible for social rules, okay? That's responsible for processing how we behave in society, okay? Now, if we go into that cluster, if we go into that cluster activity and break it down and see exactly what it is that's actually driving that activation, we get something very, very, very exciting indeed. And now this graph here is effectively the percentage signal activity across the four conditions, across the different conditions in the orbitofrontal cortex. Now I've drawn little arrows here just to highlight the take-home message, okay? Here we have, here we have heterosexual females. Here we have homosexual females, heterosexual men, and homosexual men. The yellow bars, the green bars correspond to the male attractive faces, and the red bars correspond to the female attractive faces. Okay? Now, what I want you to see is the similarity in profile, if you like. The heterosexual females and the homosexual men show the same kind of activation profile in the orbitofrontal cortex, as do the homosexual females and the heterosexual men. Okay? So here, for example, if you take the heterosexual men, for female faces, they're powering through their orbitofrontal cortex, okay? And they're not really sort of activating that much for the male faces. The same thing for the homosexual females. So the question is, out of this study here, is the orbitofrontal cortex the area of the brain for sexuality, for sexual preferences? I don't know. Well, it's up to you guys to decide. Okay? But this is very exciting data showing MRI, fMRI, actually interrogating, if you like, showing us more about sex and sexual preferences. What about lying? Okay, can we actually use MRI and fMRI to understand more about the cortical processes involved in lying? Well, lucky for us, we've got a formal test. We've got a formal way of actually measuring deceit, and it's called the guilty knowledge test, okay? So, take, for example, the crime of murder. Okay, if the crime of murder was carried out, the police would withhold information from the crime scene, okay? So only the guilty party, the murderer, okay, the suspect, would actually have knowledge of these acts, would have guilty knowledge, for example. Now, I did actually want to show you a guilty knowledge test here and now, but again, I wasn't allowed to bring the facilities over, but I did actually produce a series of pod and vodcasts, which they're free to download, which you can subscribe and download in your own time. If you go to this website here, podcast Aston ACUK/podcast psychology.html, you can download the guilty knowledge test with GSR, fMRI, TMS, everything, a whole collection of them. And they were done together with John Woods here, who's the expert with this kind of technology. So what about MRI and lying? Okay, can fMRI tell us anything about lies? Is the amygdala actually activated when you tell a lie? Oh. Got it. Okay. Well, this study here came out last week, believe it or not. So it's hot off the press. Okay. It's a study by a Japanese group, and they did something very, very clever. And I'm going to show you, if I can, absolutely everything. Okay. So this is 15 subjects. Okay. So it's the mean response for 15 subjects, and this cluster of activity here is the amygdala. Okay? It's the same activation, it's the same cluster, but it's in a different orientation of the brain. Okay? Now, they did something very, very clever. Okay? What they did was they asked their subjects to tell a truth and a lie. So they asked their subjects to recall, when they're in the brain scanner, an aspect of their past life. Okay? So tell me about your life. Make it the truth. Here. Tell me about your life. Make it a lie. Here. When they put them into a scanner. Very exciting stuff, I hear you say. Okay, but they also had two extra conditions. Here, we've got deceitful truth and deceitful lies. So here, okay, tell me about your life, okay? Tell me the truth. And then when they're heading towards the scanner, a confederate, a secret experimenter, grab them, put them to the side, say, yeah, make it a lie, okay? Okay, so it's an experimental measure of deceit. Again, here. Same thing. Tell me about your past. Make it the truth. Make it a lie. No, make it the truth. Make it the truth. Okay? So the subjects in the scanner were actually processing deceit. Okay? They thought that the key experimenter didn't know about the confederate. So it was a real measure of deceit. Okay? And ecologically valid. The kind of deceit that you would feel in everyday life. And what they found, if you see here, when you're actually doing the deceitful tasks, get a main effect. It's powering through here. So anxiety was controlled. The subjects weren't overtly anxious because they were actually asked to tell a lie. Okay? It's the processing, the cognition, if you like, of deceit that we're actually capturing here. So it's getting exciting. My good grief. Oh my. So what does the amygdala do? Okay? What does this area of the brain actually process? Okay? What's the common thing, okay, that great white sharks, lies, and pretty people have in common? Well, it's this. Okay? The amygdala is a central part of the brain that takes in responses from the different modalities, and it assesses the need for socially relevant action. You see somebody that's attractive across the room, you're assessing whether or not, do I walk over there? You know, is it actually, you know, am I going to speak to this person? It's a cost reward scenario that I'm going through in my mind. A lie, okay, if you tell a lie and you're picked up on it, okay, you have to act upon it straight away. I told a lie. Oh my God, he's got me. You know, you're actually processing action. And of course, a great white shark, there's clear action that you need to do there. Great, okay. So that was all I wanted to talk about with regards to MRI and GSR, okay? Now, we've got 5 minutes left before the end of the talk. Now, what I want to do is to talk about another technique, okay? I want to talk about a technique that's pretty new, actually. In fact, it's only been around for 5 years, okay? And really, it's the stuff of Star Trek. It's the stuff of science fiction, okay? And we've got it here. It's very cheap to use, okay? And the information that it gives us really is quite astounding. You see, there are limitations with GSR and fMRI. Okay, these are very powerful techniques, don't get me wrong. Okay, we've learned a lot by these particular techniques, but we don't know why the areas of the brain are involved. Okay, we show people in the scanner pictures of pretty people, and yeah, their amygdala activates. Why? Yeah, processes for future action. But we don't know if the amygdala is actually necessary for that process. Okay? We don't know if the amygdala is actually just doing something in the background. Okay? Now, with this technique, we can take out that part of the brain. Okay? We can stop that part of the brain from working, and then if you can't do the task, we can infer necessity to that part of the brain. And it all began with this guy here. Okay? This is Phineas Gage. Okay? Well, it's not him. That's Phineas Gage's skull. Okay? Phineas Gage was the man who actually owned this skull, I suppose. Now, I don't know if has anybody not come across Phineas Gage before? Brilliant. Quite a few. Fantastic. Phineas Gage was working as a foreman in the New England and Burlington Railroad about 1810, I think it was. Okay? And his job was, on a particular day, was to work as a tamping man. Okay? Now, as a tamping man, he had to find a rock in the way of the railroad, put a bit of dynamite in a niche, in a little crook in the rock, tamp it down with a tamping iron. The tamping iron was 2.5 feet long by 2.5 inches thick at its widest point. And then what he would do is he would retire to a safe distance, blow up the dynamite, blowing up the rock, clearing the way for the railroad. Okay? On a fateful day in December, Phineas Gage was standing over the rock with the tamping iron, and the dynamite went off. Okay, and it blew the tamping iron through his head, okay? And in fact, blew it underneath the zygomatic arch here and through his frontal lobes. And it landed about 100 yards behind him, also with most of his frontal lobes as well. Okay, now the remarkable thing for us is that Phineas Gage survived, okay? In fact, he was conscious, quite sentient after the accident. Now, I'm not saying he got up and danced or anything like that. I mean, he had a metal bar, like, pushed through his head. But he was alive, and he can actually comment on his feelings. Now, I prefer this picture here, just because it captures the emotion of the Phineas Gage accident, okay? Now, one startling thing happened with Gage, okay? Yeah, he had a catastrophic accident. It was a horrific accident, and he was horribly disfigured, true. But, okay, what happened was that Gage was no longer Gage. His doctor actually said that the normally tidy, very attentive person who would stick to schedules and was a model foreman came back after the accident, and he was drinking, he was lewd, he was inappropriate to members of the opposite sex. He just was not Gage afterwards. Now, Gage tells us something very, very important. And it may be quite simple and straightforward to us now, because we're sitting here in the 21st century, but Gage tells us that part of the brain is actually necessary for a behavioral process, okay? For social rules, okay? We know how to behave in society. We remove that part of the brain, this part here, your frontal cortex, we don't know how to behave in society. Now, that may seem straightforward. At the time, it was radical stuff, okay? This really revolutionized neurological science. So, okay, so 100 years after Gage died, this guy was born. Okay? And this is Michael Faraday, the great Michael Faraday, Professor Michael Faraday, Fullerian professor of chemistry. Some say the greatest scientist ever to walk the face of the earth. He was pretty good, okay? And he did a lot of experiments. You may recognize him from this thing here. It's called a 20-pound note, okay? And if you look down here, this is actually a rendition of Michael Faraday, and he's actually demonstrating his most famous experiment. Okay? And this is electromagnetic induction. So he's there at the Institute of Chemistry, and he's got this apparatus here that looks quite spookily like the apparatus I've got in front here, which I know is not going to work, but I want to show it anyway. Okay, let me just talk through exactly what this is. A signal generator, which is sending an electrical current into this circuit here, which is your primary circuit, and this is a secondary circuit. It's not connected in any way, shape, or form to this circuit here. Okay, now I'm going to try and induce a secondary current in this circuit here, and I'm hoping that this light is going to light up. Okay, now bear in mind these circuits aren't connected in any way. Can we dim the lights? Can we dim the lights? Oh, wow. This is so exciting. This probably won't work, okay? Wow, check this out. You guys at the back, can you see that? So that light is actually switched on, okay? These two circuits aren't connected in any way, okay? Now, this is quite remarkable, and the relevance of this experiment is going to become more remarkable in a few minutes' time. Now, I'm going to pull this metal bar out. Yeah, the signal is attenuated. But I'm hoping you can still see that. There is actually light in this LED. Can anybody not see that? Can you see that? Can you see that? They can see it, so it does exist. Okay? Now, this is quite remarkable. This is the most fascinating experiment out. Okay, what we've done is we've induced electricity. Okay? We've induced electricity in a circuit, in a secondary circuit that's in no way connected to this primary circuit. Okay, it's air-cored, if you like. Now, if this experiment didn't work, we'd all be doomed. Okay, we'd all be back into the dark ages. Thanks, Mike. We'd all be back into the dark ages. Okay, this process here, okay, this simple demonstration is the principle, is the basic skeleton, if you like, of all motors, of all electric motors. So the motor in the projector light, the motor in the ice cream maker, the air conditioning unit, computers, we won't have any of that, okay? So why am I talking about this? Well, it's also the basic skeletal plan of transcranial magnetic stimulation. If you imagine this circuit here being your brain, okay, and inducing a local secondary electrical circuit would stop function in the brain. Okay? And it does so for milliseconds, and it's very, very safe. Trust me. And I'm going to show you, hopefully, a video of it in action. Okay, that's that. Fantastic. Okay, I want to show you a video of speech arrest. Okay, so I'm going to show you a video of somebody not in control of their brain. It's very small, but I hope you can all see it. Come on.
Push that in, okay? And when I say stop, pull it out. Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, no, 7, 8, 9. Okay, that was pretty total. On the other side, in the matching position, count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29.
By Charles Epstein. So did you all see that, okay? On one side of the brain, okay, when TMS was applied, okay, this chap couldn't count. Okay, couldn't do anything. He just couldn't. He was like, blah, blah, blah. He was going like that. But on the other side of the brain, he had no problem. Okay, so what Charles Epstein had done was he'd induced a local electrical current, part of the cortex on one side of the brain, and we found out that that part of the brain was necessary. Okay, for speech. This is speech arrest. This is TMS in action. This all started with Phineas Gage. Take out parts of the brain, take out function in the brain. You can't do a particular task. Got one more video I really want to show you before I get kicked out. Get rid of that. Okay, I'm going the wrong way. Okay, now this next video is taken from a lecture that I delivered a couple of weeks ago, and it really is quite fascinating, okay? So what we did was we applied TMS to a student's occipital cortex, okay, to the back of the brain, and we wanted to induce phosphenes, okay? Phosphenes are those strange amorphous blobs you see in your visual field. If you squash your eye, okay, you can actually see them. Those things are phosphenes, so they can occur in two ways: actual physical stimulation of the eyeball or cortical stimulation. We did it with cortical stimulation. Okay, let's do this. Okay.
Oh yeah, if you close your eyes and relax, and all you're looking for is just white dots. Do you see anything?
No.
See anything?
No.
Okay. Just going to turn it up as such. So it's now 38%, and it sounds like that. See anything?
No.
See anything? See anything? See anything? Nothing?
No.
Okay. So I'm just going to turn it up a touch more.
Individual differences. You know, we've got to explore around the visual cortex.
Okay, it's now 48%, and it sounds like that, yeah? Do you see it? Do you see something? What did you see?
White blob. Like shut.
That's fantastic. Yeah. Wow, yeah. You really saw it? You saw a white blob? Just...
Right.
That's brilliant. Okay, it's about 46% of the population actually can experience phosphenes. Okay, so we've actually got phosphene production on tape as well. So this is amazing. Thank you very much, Catherine. Thank you. Yeah, definitely. Yeah. All right. Yeah.
Yeah, you can see. Yeah. Thanks, guys. You can see I was used to things not working over there as well. How surprised I was. Like, oh, it works. Yeah. You know. So that was TMS, transcranial magnetic stimulation, in action. What we did was we produced visual activity in that student's visual cortex. Didn't touch it. We activated her visual cortex. And that is it. I do apologize for running over a bit, but thank you for your attention. Thank you. Thank you. Thanks. And I do apologize about not knowing how to control this thing as well. I'm sorry.
Thank you very much, Carl. Carl actually pointed out earlier on that you need a PhD in order to use the equipment in here. What he didn't point out, of course, is that he has one and still failed to be able to use the equipment. We will have to finish very soon, but does anybody have a burning question or two that they'd like to ask Carl? At the end, you feel free to come down and speak to Carl in person, but if anybody has a really juicy question they'd like to throw at him, possibly something to embarrass him or make him feel a bit thick in front of everybody.
Well, that won't be hard. It's okay. Yeah. Question?
Using induction, it was possible to create a reaction in the brain. You could stimulate the brain. Is there any danger that the MRI can actually stimulate false readings because you're putting a huge magnetic impulse into the brain, and that actually doesn't just observe a reaction, but it creates a reaction?
I think that's a brilliant question.
Sorry, can I? The question there is, can MRI actually stimulate a response in the brain as you just saw with the TMS?
Thanks. The key difference between MRI and TMS is that TMS is a focal pulse. Okay, it's very, very focused and it's very, very quick on areas of the cortex. It's about the same level of intensity. It's about 2-3 Tesla. But MRI is actually diffused across the whole body. Okay, so that way is we don't actually get any kind of TMS activity that you would see with a TMS capacitor. Thanks. That's a very good question. Thanks.
Does anybody else have a quick question?
I just wondered, when you ran the heterosexual and homosexual, they just gave representations that the person knew what he or she was, either heterosexual or homosexual.
Yeah.
At some stage in one's life, one possibly wouldn't know which one. So is it a subconscious reaction or a conscious reaction?
Oh, that's a brilliant question, actually. This gentleman's just asked a question about the identification of your sexuality. In the study that I showed you about the orbitofrontal cortex activity. Now, that particular study actually assessed sexuality at the time of the experiment, and they used a questionnaire, a psychometric scale, to get an index of their current sexual preferences. But I fully agree with you. I mean, sexuality and sexual preference really is a very diverse thing. I mean, it's a dynamic entity. It's not a static entity. It changes throughout your life. Yeah, so at the time of the experiment, that's what they were...
Would know himself.
That's correct, yeah. Thanks.
Right, well, we'd better call it an evening just to let everybody get off.
Yeah.
Thank you all very much for coming along tonight. It's great to see so many new faces. The next talk is on Thursday, the 14th of April, by Dr. Tom Millard from Bristol University, which is entitled Zipping Up Flies. It would be great to see some of you back here for that. I don't know how you all found out about tonight's talk. We do have a talk every month throughout the year. I have an email list that I send out every month just to update people. If you'd like to have your name put on that mailing list, no Viagra or breast enlargements, I promise. Please come and see me and I'll put you onto that list. Otherwise, if we could all just thank Carl once more, and I wish you a very safe journey home. Thank you.
Thank you. Thank you.